Okay, here's my question for you. When you see anything with a pi and a 12 on the bottom, what's your instinct? 15 or 75. Yep, that's it. Okay, so as soon as you see something with a 12 on the bottom, you should understand that that's the 15 or 75. So I'm just going to practice drawing this. Where would you draw that? So it's just shy of the 24, the 2 pi, right? So would you have said it's a 15 or a 75 away? 15. So I'm going to be doing the sign of, and then what do you do instead of 15? What do you replace that with? The 45 minus 30. Okay, I don't have my formula sheet. Is it sine cos minus cosine? Is that the formula?
Yeah.
Okay, I always set myself up for brackets, replacing with trig values. My trick is always just attack the 45s because those are root 2's over 2's. Doesn't matter, you don't have to think. And then at 30, the x value is root 3 over 2 and the y value is a half. Then when you are done, I need you to go through your Astica. Sine is negative. So just negate that number. Okay, and again, you could see me not using my calculator once. That's what you would look like on an exam. Okay, 105 degrees, so I'm going to draw that. Which means I'm a 75. So again, you can do everything on this with just using 45s and 30s. What is the tan of 45? 1. Because divide those. Boom, 1, right? See it? Quick. The tan of 30 y over the x. If you flip multiply, what happens? The 2's would go, right? So just make the 2's go. So 1 over the root 3. Okay, so I need you to get me a common denominator. So I'm going to put everything with a root 3. So I'm going to change this to a root 3 over root 3. I'm going to change this to root 3 over root 3. Okay, flip multiply, what would happen? Can you already see what would happen? Those would go away. So root 3 plus 1 over root 3 minus 1. What? Where did I lose you? Good. And Astica, tan would be negative. So please put brackets around it just to say that whole thing is a negative value. Okay, last one. So 17 over 12 would go, can you figure out where it would be? 17 over 12. Six over 12, 12 over 12, 18 over 12, 24 over 12. Right? I'm good with those. So I'm a 75. And I'm not going to do secant. I'm going to do a cos. Okay, don't forget that one. It's kind of tricky even though there's an adding. This cos formula is opposite. So that's a plus, that's a minus, so make sure you read that. Okay, for secant, what am I going to do? Flip that. And cos in that quadrant would also be negative. So I have to negate and flip. I've got to do both. So that is your one outcome with your 1575s. You also might have to draw a coterminal or something like that, or state a coterminal. So what would you do if I said give me a coterminal to that value? What would you do? I could add a 24, so something like 47 over 12, right? Something like that, right? Okay, so those kinds of questions might still come into play from the first unit. Okay, XYR stuff. So XYR stuff, you should start drawing Astica, drawing triangles. So here's what I would say first. The sign is positive. So the sign is positive, well, tops, right? But then it also tells me it's in quadrant 2. Well, okay, here we go. Don't have to do any work. It's in quadrant 2. Where would you put a 5 and where would you put a 13 according to X, Y, and R? Putting a 5 on one side and a 13. So Y over the R. So the third side, I need a Pythagorean theorem. 13 squared, subtract 5 squared. You got to do a subtract here, right? I think some mistakes were made on the test of adding. Make sure you know if you're finding a longer or a shorter side. So your calculator should tell you 12. And then you should ask, is it a positive or a negative 12 on the drawing? Negative. Okay, so here's what I know. Here's the sine, which was obviously given, and the cos, x over r. This is just side work. Okay, so now if I doubled that angle, this is what this means. If I was to double that angle, I would now want to know the cos value. So go to your formula sheet. This one gives you 3 options. It does not matter which one you use. You can pick 1, 2, or 3 for that. I'm going to go with the first one. I'm picking the first, so I have a trig value squared minus a trig value squared. Okay, so now I go to my trig values, and I've already got them over here. So negative 12 13, 5 13ths, okay, here's where a lot of problems happen. People type this into your calculator and not think about your negatives. If you square anything, it should turn out to be what? Positive. So don't forget that. Like if you're just typing into your calculator and somebody types it wrong, like this is a wrong. If you type this, it's going to be negative, right? And that's not what you want. Typing properly would look like that, which would turn positive. Okay? But just look at your numbers. You know without your calculator. Is that positive, negative? Okay, the sine value for this angle, if it was doubled. So now I only have one choice of a formula. So I'm going to go a bracket there and a bracket there to replace them with trig values. And some of you might work better in your brain if you made that number a 2 over a 1. It might help you. So just looking right now, will your answer turn out to be positive or negative? Negative. There's only one negative in there somewhere, so that's negative. So 2 times 5 times 12. Pause it. I have a random question for you here. If I doubled that angle, what quadrant did I actually end up in? Looking at a positive cos and a negative sine. Would this make sense? What quadrant are you in now? You're in quadrant 4, right? Look at that. If I doubled that, would you probably end up in 4? Makes sense, right? Okay, exact value. So you need to look at this and recognize the formula. That's 1 point on your test. Which formula looks like cos minus sine? looking at your formula sheet. Cos cos minus sine sine. Did you pick cos A plus B? Okay, so this is 2 points on your test, so there's 1 point. If you wrote me this, that's 1 point. Now, so 3 plus 5 is 8. I would say I don't recognize this angle, 8 pi over 24. I don't recognize it. Is there some kind of math move I can do on that value? Can I reduce some stuff on that? 8, 24, can you just reduce those numbers? Divide by 8, so it would turn into a 1 pi and a 3. Oh, that looks familiar, pi over 3. So now what do? You grab a unit circle, you go to pi over 3, and what is your trig value? That's what I'm looking for. Okay, recognize the formula. Sine cos minus cos sine. What formula does it match? So I found this one, sine A minus B. So sine of A minus B, so that ends up being 45 degrees now. So I can now grab my unit circle again, go to 45, and what is the y value? Okay, so 2 points, recognize the formula. 1 point, get me that trig value somehow. Okay, we're going to do, yeah, this is kind of basically the same as your test question here. 2 different angles. So let's talk about angle A. Cos is negative. Cos is negative. It could be over there on the left somewhere. Don't know. Sine is positive. It could be anywhere on a top. Now it tells me that angle A and angle B are in the same quadrant. So therefore, they would have to be in 2. Okay, so I'm going to go to the bottom here a little bit and give myself triangles. X, Y, R, you always jump to triangles. So negative 8 and a 17, cos X, R. So I need what on the other side? I need 15 plus or minus plus 15. Okay, now I'm going to jump to B. I have a 24 and a 25 because I know it's a Y and an R. So this is all last unit stuff. The last side is a 7, positive or negative 7. Okay, now just to make your life easier, I'm going to go, what is the sine of A, the cos of A? What is the sine of B, the cos of B? And I'm going to write all those down there. So those are called trig values. Those fractions are called trig values again. Okay, now that we did all that work, we haven't even started the question. Cos A minus B. So you go to your formula sheet. Same with sine A minus B. Can you just write me a bunch of formulas? So write down the formulas, just copy them down. If you want to do your next step, that's inserting the numbers. If you are okay with that, that's fine. Okay, so what I do is I give myself 4 brackets, and then I'm ready to insert my trig values, and then I have them all down below, so they just have to get copied and pasted because you have them all organized down below, right? Okay, that on your test is worth like 6 or 7 points or something like that. That one question. Almost exactly the same. You're going to add or subtract 2 angles together. Okay, so do all this kind of work, label them so that when you're ready to use the formulas, you just have to insert them. Okay, proofs. You have 2 proofs on your test. I'm going to say one is called an easy medium level, and one I literally will have copied and pasted from the booklet that you're doing. 3. You get 1 on your exam. You get graded 1 point for correct substitutions, 1 point for showing me some kind of logic process, and 1 point for your algebra.
Is it a smaller test? There's only 2 proofs.
Yep. Well, I'll have 1 75 15. I'll have 1 like that. I'll probably have 2 like that. 2 trig proofs. Yep. Okay, so in your booklet, so remember I gave you this booklet? I started you kind of easy mediums. So you'll have 1 kind of easy medium. And then at the end here, do you see that I have trig proofs from provincial exams? And then, so all these ones here at the end are provincial exam ones. All those, I've literally copied and pasted 1 of them on your test. So, okay? Okay. Which side? Left or right? Left. What strategy? Common denominator? What do you need in your common denominator? Gonna have to put a cos of t and a sine of t. You're gonna need them both in there. If I look at my first fraction, did I do anything to the bottom? Nope. So I don't do anything to 1. If I look at the second fraction, did I do anything to the bottom? Yes. There was a times by sine. So I would also have to times the top by a sine, making a sine squared. Now what? Top stuff, formula sheet, corner. On your test, you do not get your formula sheet. You get the normal one. So guess what? These are the 3 that you get. So you have to visualize them all moved around, right? So if I had 1 minus a sine squared, right, it would be the same as a cos squared. Now what? There's a cancel. I can do that here because everything's times. So 1 of the coses is on the bottom, top. Okay. And then a cos over a sine, that ratio is the same as a cotangent, and you're done. So that would be an easy level if I was to classify it. Did you notice I never put an equal sign? Okay, now what? What side? Anybody have an instinct? What's up? You want to change the cotangent squared? Sure, to cosecant theta minus 1. Okay, if you are having an instinct to cancel something, you need to fight that instinct. That is not happening. Why? There's adders. That's not a cancel, right? I'm guaranteeing you somebody really wanted to do it. You don't have to admit to it, but I'm guaranteeing you somebody is going to want to do that. Not allowed. So what's the next strategy then? Something to do with this top here. Something to do with this top right here. Some kind of math thing. Maybe you learned it in grade 11. Factor?
Oh, yeah.
What style is that?
GCF.
Difference of squares. Okay, so I would go 2 brackets, cosecant theta plus 1, cosecant theta minus 1. That's a difference of squares. You recognize it? Now what? Now there is a cancel. This is legal because it's timesers now. This times this divided by this. Okay, now you would have 2 options at this point. Option 1 is you could work this to a sign flip, or you could go on this side and split the fraction. So I'm going to go over here and I'm going to split this. Okay, again, you could have worked on that side still. So this is what a split looks like. And then I can replace the sign flip with a cosecant. And then this fraction has a same thing, so that is 1. So that would be more of a little bit more to a medium. Okay, and then we have 2 trig equations. We're done. Okay, so trig equations. What is your first step? Because I do not like having cotangents in this and cosecants in this. This is awkward. So what would you do? You're going to replace something with the corner stuff. Okay? What's the hint when you look at the corner stuff? You usually want to replace squared things, right? The corner stuff has everything with squareds in it. So then, that's what I'm looking at. Is there some kind of replacement for that? Okay, so I replaced it. Does this look better? Because now I have everything with the same trig stuff, right? I have cosecants, squareds, and cosecants, so that looks better. So I'm going to make this a trinomial, just with some algebra stuff. is this factorable is probably where I would go next. That's algebra. So can I factor this? Multiplies to 3. Yep, looks like I can. What if it doesn't factor? What do you got? If something's not going to factor, what else could you do? Formula. Some people like the formula no matter what. They don't even try to factor, they just formula it. That's fine too. Trig value. Trig value. Okay, I had people on the test getting to trig values and they forgot where they were going. This is a trig value. So you are at like 25% right now. So you have to now go into the angle brain. How do you figure out what this angle is? So first of all, I don't want cosecant anymore. So I'm going to change it to sine flip, sine flip. As a trig value over here with 1, boom, that's a unit circle thing I'm seeing. So I would look at my unit circle, and I'm trying to find an angle where the height, the y value is 1. So my eyes are there. And how do I know how to answer that? So it's told me this. So I'm in a radian, and then pi over 2. Done. Because I'm not, this isn't the 2 pi k thing, right? Because it just said to stop, not go on forever. This one is not on a unit circle. So I go to my Astica, step 1. How do I get myself into the angles? Inverse. What do you not push? Don't do negatives because we already put the negatives into it. What do I need to check at the top of my calculator before I push buttons? Radians. Sine inverse, bracket 1/3. The number your calculator gives you is called a reference angle. It's telling you your space, like that. So what is the final angle? What would you do? This one would go pi plus that distance. Make sure you go 3 decimals so I don't have to deduct you. So all of last unit except for the first step. That was all we added on now. All right, last question. Okay, so you should recognize right off the bat that there's sine squareds and coses all mixed in an equation, so not good. So where do you look for replacements? Squared stuff, because that's what this corner, usually we're going to that corner of our formula sheet. So sine squared could be replaced with make sure you write that out correctly. Good? That's my replacement, so then I'm going to have to make sure I times that by a 2. step 1 is replacement. Step 2 is move this to a trinomial, but I also will have to do that, distribute the 2. So 2 minus 2 cos squared. How did your algebra go? Did you move this over so you have a 0 as well? Okay, I hate factoring with negatives like that, so I'm going to go, this is positive, so change, change, change. So what I said was I times everything by -1 in that whole thing. That's fine. Or you could have moved it to the other side, which does the exact same thing. Try to factor it. Again, if it doesn't factor, we have a formula. Okay, what you got here was the trig values. So again, what are you looking for? The angles. And then this one also says we should find the angle in a degree. So I actually see this from a unit circle. So where are the x values a half on a unit circle? X values a half on the unit circle. I see this trig value on a unit circle as well. So where's the x value 1? Over here. So you're going to have to be careful because of the question. It says you could include 0 and you can include 360, so you are going to have to answer both. Okay, so on your test, I think I put 2 or 3 of these questions, and one other thing I could ask is that you solve it for all real values, so make sure on that one you do your plus 2 pi k stuff, KEI. Okay, so substitute, do your algebra, which will have some distribution rearranged to a trinomial. Try to factor. If you can't, you have a formula. That step gets you what I call a trig value. From your trig values, you could go one branch where you say, do I see a unit circle angle? If not, you got to inverse, astica, finalize. Okay, on that one pink paper I gave you, kind of had all of those steps. Where grade 11 you learned all these algebra tools, all the factoring to get a trig value. Once you have a trig value, here's kind of the steps. If it's not on the unit circle, go astica, inverse, finalize. Okay, so unit circle, if not, steps. So that pink paper, again, that's all those steps.